Welcome to the introductory presentation about eXtensible Binary Universal Protocol. This presentation covers concepts and technical aspects of the project and ends with short demo of the editor tool included in the current prototype implementation. XBUP is concept of a binary data protocol which has strong focus on abstraction as the primary concept across multiple levels. While on the lowest level data are basically represented as tree of binary blobs, protocol defines mechanisms to build complex data types on higher levels and also includes transformation layer for automatic or manual data conversions and compatibility handling. Goals for the protocol are universal. To support as wide types of data as possible, delivery methods like storage, streaming, parallel processing. Independent. This means no dependency on any specific platform, architecture or programming language and neither dependency on some product, company, country or spoken language. Declarative. Protocol should be self-sufficient for data type definition and with the ability to build data types by combining existing ones. Normative. There should be an option to provide reference form for the data representation. Flexible. Compatibility and extensibility should be included and it should be possible to use only part of the protocol if desired. Efficient. There should be support for data indexing and caching and an ability to compact or to compress data to various levels. As to what motivation is behind this project, it would be great to have structured binary data format with well-defined meaning which could be easily viewed or modified with both graphical and textual tools and with support for multiple languages and syntaxes. Another use for this protocol could be to provide both independent API and data interchange format and with automatic transformation between both of them, and it should be possible to utilize the protocol to enhance approach for modular application design. With multiple levels of expressiveness and capability to define unlimited number of additional properties, it should be also possible to utilize the protocol for definition and storage of specialized scientific data. As the protocol should support both external or included specification, it should be possible to construct self-contained package usable for long-term storage. These capabilities should make it possible to use the format for example for multimedia files, like audio, video, animations or 3D objects, data serialization of non-structured data as well as remote or local method execution calls. It should be also possible to use the format to store data and metadata for file system or compressed archives. Dynamic numeric values should allow to support data in basically unlimited sizes and transformation layer should allow to handle segmented, paged or fragmented data as well as atomicity of actions for parallel access for structural or maybe even database data. As an example, let's consider image format. While bitmap image might seem to be simple, there is still factors like color model, palette and compression to consider. But much more complexity to image format could be introduced with metadata related to image creation, especially with modern smartphones which boost wide variety of sensors. If unified method for storage would be available, same metadata format could be used for different formats as well, for example for audio or video recordings and so on. Next slides attempt to explain more technical details starting with the basic goal to build universal protocol. Basic premise is that it should be possible to include any reasonable binary data, but still attempt to adhere to the structure of the data when possible. Primary point of view for abstraction should be ordered set and sequence as defined in set theory. Data in protocol are organized as a sequence of octets, also called bytes. To represent single value from countable set, varying length encoding is used. It combines unary encoding to encode length and binary encoding to represent value. On current slide, there is list of example non-negative integer values on the right side and matching binary codes on the left side. Values are shifted so that there is only single code for each value. Tree structure is built using block with children blocks. This simple approach should provide sufficient capability to represent wide range of different structures of data. More complex data can be mapped to tree using pointers and references. As the data stream can also carry infinite stream of data, support for sequences with infinite length is included, usable also when length is not known in advance. Single document is typically represented as a single block, but there can be additional optional tail data present. There is also option for file header, which contains information about protocol version and contains padding data to avoid issues in systems which uses file type detection by reading beginning of the file. File header is not necessary when protocol version is known already, for example in multiple data streams connecting to single service. Block consists of two parts: sequence of values encoded using unary binary encoding and sequence of child blocks or single data blob of general data. There are actually two values at the beginning of the block which are used to specify size of space available. If there are no additional values, second part is considered as a general data blob instead of a list of child nodes. There is also support for blocks with infinite or dynamic size which have to be terminated with 0 mark. Here you can see few very crude examples of blocks as hexadecimal codes of the byte values. It might be slightly easier to understand this with highlighting size of first part red, size of second part blue and child blocks as yellow. As next step, first two attribute values in the data blocks are used as a reference to specific data type. Rest of the attribute values and child blocks then corresponds to the defined sequence of value types as specified in the type declaration. Types can be organized into catalog of types and linked to document. Protocol itself defines one main catalog which contains set of basic block types which can be used both directly in documents or referred to so that more complex types can be constructed. Catalog can also contain functions or methods definitions for various purposes like data transformations or remote calls. Data types can have structure of dependencies, and there can be also additional properties which should allow more methods for handling the data. Type can, for example, specify that value is a real number with specific precision, but it also have specific unit of measurement. This should prevent mixing different units and allow unit conversion, often automatically. As part of the protocol, there is also support for data transformations included. Transformations can be used for automatic conversion between different data types and their versions and can be provided to applications as a background service or separate library. This should allow to provide new functionality without necessity to get new version of the applications if desired. Similar technique is, for example, used in multimedia frameworks for adding new codecs and container formats. Example here shows simplified use case for bitmap editor application which uses service to open files. This arrangement allows to add support for additional image file formats with different compression without necessity to modify the application itself. Transformation services can be also executed remotely if desired and combined together as computation nodes to form some kind of data processing cluster. Execution nodes can also provide local copy of catalog of types for faster handling. Another options is to use remote nodes for database or backup purposes. One of the basic tools is Document Editor. It can show document as a tree, text or as binary data and provide support for catalog. Editor can be extended with various visualization tools for example viewing pictures, playing multimedia or editing specific structured data, as well with custom syntaxes or manual and automatic transformations. Prototype implementation is written in Java and few included tools have currently only very limited functionality. Editor contains few sample documents which can be used to check out document tree and see stored data. Data blocks can be viewed as a property list, show type information, textual form or as binary data. When available for specific data type, custom viewer or row editor can be shown. Editor also contains browser for local catalog which is updated from central repository and can be browsed and even currently edited for testing purposes. There is also some basic support for adding and editing blocks. Project is still in early development stage and lot of work need to be done. While libraries and support for catalog are partially covered in the prototype implementation, work on execution service barely started. Support for transformations and programming language are still just a concept, also missing is definitions of wide range of types and data formats. If you are interested about this project, you can visit project's website and browse documentation or try current prototype implementation. Project is open source using Apache license with source codes available on GitHub. You can also join discussion about project on Element Chat or write an email. That's all for now. Thanks for watching and have a nice day.